Hello my friends, and here we are at the end of this training implementation. We just have to do one final print to print the training result, and we're not going to make a classic print, we're going to make a very exciting one because we're going to make a dynamic print, meaning that we will get the average score for each episode but in a dynamic way, meaning that episode by episode we will see the average of the cumulative reward evolving over the episode, but we're going to make an overwriting effect, meaning that each of these lines printed will be removed to give place to the next one. And of course, we will keep the average reward over 100 episodes every 100 episodes. Okay, so it's a bit of an advanced print, but you won't be disappointed at the end by the result. Alright, so here we go. First, we're going to make that first dynamic print, which will print those average scores for each episode with that overriding effect from one episode to the next. Alright, so here we go. We start with print. Then we're going to start with some quotes because we're going to use the format function. So, first in the quote you enter the string, and then outside of this quote you're going to add dot format, which will contain the variables corresponding to the values that we're going to enter inside these quotes. Okay, so that we know that's a usual technique of printing. So first let's enter the print, and then I'll show you how to make that dynamic overriding effect. Alright, so we're going to start by printing episode, the episode number. So that is just the string, and then to add the number, we're going to add a space and then this pair of brackets, like that. Then we're going to add this \t, which is a tab character just to add some space. And then we're going to add average score, which will be, of course, the average score, meaning the average cumulative reward over the last 100 episodes up to this one, unless we still haven't reached 100 episodes, in which case it would be from 0 to this one. So then we're going to add in another pair of brackets like that. This time, since it's going to be a float, and since we have to choose the number of decimals we want to have up to the comma, we're going to enter this colon dot 2f, meaning that we will want the average score to be printed as a float with 2 decimals after the comma. Alright? And here we didn't have to enter anything because it's just an integer, which is the number of the episode. Okay? So all good with this, and then inside the format function now, we will have to enter 2 variables. The first one that will give us the value of this episode, and the second one that will give us the value of this average score in this particular format. Alright, so let's start with the first variable, the obvious one. The variable that will give us the number of the episode is, of course, our episode loop variable. And so that's the first variable we enter here. Okay, good, that was the easy one. And now the more difficult one, how we're going to get the average score in a variable here. Well, unfortunately, we don't directly have it, so we'll have to compute it. But what we have is this, scores on 100 episodes. And so according to you, how do we get that average score thanks to this scores on 100 episodes? Well, by using, of course, the mean function by the NumPy library. So that's why here I'm calling the NumPy library, from which I'm calling the mean function, which will take as input, of course, our scores on 100 episodes variable. Alright, so note that as long as we haven't reached 100 episodes, actually the scores on 100 episodes variable will contain less than 100 episodes, and therefore we'll get the mean of less than 100 episodes, but at the end, of course, we will get to 100 episodes. Okay? And now, finally, let's create that dynamic effect with the overriding effect. So the trick to do this is simply to add at the very beginning here, inside the quote, a \r, which is called a carriage return in programming, meaning that the cursor will return to the start of the line when printing. And so when you use it in a loop, well, it will allow the newly printed line to overwrite the previous one, which is exactly the effect we want to create. You will see it's going to look very, very nice. We'll have a dynamic effect in the console. But then that's not all. We also need to add at the very end, but inside the parenthesis of the print function, of course, a final argument, which is the end argument, and which we will have to set equal to a pair of quotes. Okay, just like that. And that means that after printing this line, it won't automatically add a new line. And this is crucial to create that overriding effect caused by this carriage return \r. Alright? So great, we have the dynamic printing, but then remember that we also want to keep the average score on 100 episodes every 100 episodes, and therefore we're gonna naturally make a new if condition here that will check whether we are every 100 episodes. Okay? And so how we're gonna do that? Well, you know the trick. We're going to use modulo again, that percentage giving us the rest of a Euclidean division of an integer by another. And what will be that integer? Well, that's of course going to be the episode, because we're going to check if the rest of the Euclidean division of the episode by 100 is equal to 0. All right? Because if yes, if that rest is 0, then that means that we are every 100 episode. If episode is 100, then the rest of this is 0. If episode is 200, then the rest of this is 0 as well, because 200 equals 2 times 100 plus 0. All right? And so, if we are every 100 episodes, what are we going to do? Well, we're going to do this exact same print, but without that dynamic overriding effect. And therefore, right here, I'm going to paste that same print, and then we're going to remove at the end this end argument. We just remove it, and so then this print will stay. Perfect. And now, according to you, what else do we have to do? We have to do one final thing that is very important. I'll give you a hint. It has to do with the way the Lunar Lander environment works. Let's have another look at it in Lunar Lander Gymnasium. Let's have a look again at the rewards. If you remember, there you go, an episode is considered a solution if it scores at least 200 points. And therefore we need to check that, because if this happens, that means we win. And so we have to say this in the print and also save the model if we win, because it would be nice to keep a winning model. That works very well. And so, back into the implementation, we're going to create below a new if condition, which this time will check if, well, the mean of our scores on Google Colab will find it. There we go. If the mean of our scores on 100 episodes is larger than 200, and we have to add 0.0 to make it a float, well, if the average score in 100 episodes is larger than 200, well, time to say we win. And so, let's paste the previous print again, and let's change this the right way. So first we're gonna replace this by a /n to jump a new line, and then say environment solved in, and then in brackets we're gonna enter colon D because it's gonna be a double integer. So environment solved in a certain number of episodes. I'm going to add here episodes. Then we're good for the average score, that's fine. However, in the format function, here, do you think we have to keep episode or change it a bit? Well, actually, if this average of the scores on 100 episodes is larger than 200, that means that in fact we actually started winning from this episode number minus 100, because this is a score over 100 episodes. So here, as you want, you could either keep just episode or subtract 100. That's up to you, okay? Let me actually zoom out a bit so that you can see better the whole code. Another one. I hope it's not too small for you. Let me know in the comment if you can still see well. I can always re-record this. Okay, then we will also remove this end argument at the end because we don't need the dynamic overriding effect. And now we're good. And so, now what are we going to do? Well, since we have an intelligent AI that is able to land on the moon, well, time to save its model parameters. And how do we do that in PyTorch? Well, first, we call the torch library, from which we call the save function, which will take as input two arguments. Well, first, the model parameters that we want to save, and then second, a file in which we want those model parameters to be saved. So let's enter the first argument. How do we get those model parameters? Well, first we have to call our agent. Then from our agent, we're going to call our local QNetwork. There it is. And then from a local QNetwork, we're going to call a method that will return to us in the dictionary those model parameters, and that method is state underscore dict parenthesis. Okay, perfect. And then the other argument, the file that will contain those model parameters, and well, we simply have to enter a name of that file, so we can call this checkpoint.pth. Okay, perfect. And then now we have one final step, meaning one final line of code we need to do in this training for loop. According to you, what is it going to be? Well, now that we solved the environment, now that we have an AI working properly to land on the moon, well, it is time to exit the training loop, right? Because we don't need to do more training. And how we're going to exit this training? Well, with a simple break. And that's it, my friends. We are now ready to run this training for loop and observe some very exciting training results. All right, so are you ready? Let's do this. Let's do this now. But first, it's possible that because we implemented a lot of code, your session actually expired. So if that's the case, what you only have to do is click runtime here and then restart runtime. Okay, don't do restart and run all because we still have the results visualization, which I want to show you in the next tutorial. But at least restart the runtime and then rerun the different code cells we implemented together one by one until reaching this one. Okay, and once it's done, well, now is the time to run this last cell we did. So here we go. I'm going to do it in 3, 2, 1, go. And here we go. Now the training is launched. And you can see the dynamic printing of the episode with the average score. And as you can see, at first we start with some negative average scores, which is completely normal. You know, we just need to give some time to the AI to explore, to do some exploration, to train, to learn, and to update its model parameters, to update its Q values. Basically, it will take a bit of time before we see a better score. But as you can see now, we already increased the average score. You can see it increase a bit over time with this dynamic printing. So yeah, there we go. We started at minus 146. Now we're at minus 104, which is pretty good. And now there you go. We're over minus 100, minus 95 for the 200 episodes. And now minus 91, minus 89, minus 86. So you see, it is improving over time. It is amazing. The deep Q-learning model works very, very well for this environment. And it keeps increasing over time, over the episodes. Now we are at episode 230 and the average score keeps increasing. And soon we will have a positive average score and mostly an average score over 200. So yeah, let's just continue watching and very, very soon we will see some positive average score. I can't wait to finally discover the score. Now we are at episode 263 and we have reached an average score almost close to minus 50. So as you can see, it is still exploring a bit. It is still doing a bit of exploration. It is still learning thanks to not only the deep Q-learning model we implemented, but also remember that epsilon greedy action selection strategy. And now there we go. We are over minus 50. We're at minus 45, minus 47. And we have reached almost the episode 300. We're approaching 300 now, and we have reached minus 47, which is completely normal. You know, it always takes time for the AI to learn, to update its model parameters in order to achieve the desired performance. But now we can see the average score kind of stagnating. It is still not increasing, but that's probably because, you know, sometimes it still needs to do a little bit more of exploration, and soon enough, well, it will improve. And there you go. Now we are over minus 40, minus 37. That's perfect. And we have reached episode 329. Minus 31 now. We're close to the 20s, the minus 20s. There we go. Minus 20s, minus 28, minus 27, minus 25. You see, it keeps increasing. Now it keeps improving. Oh, wow. It's going really well. Now minus 13. We're getting super close to the positive reward. Minus 10, minus 8, minus 6, minus 6. We have reached episode 349, minus 7. So still doing a bit more of exploration now maybe. Still learning, still updating its parameters, its model parameters, still updating the Q values. We're decreasing a bit, now minus 10, but then that's probably because of some more exploration. Minus 4 now, minus 2, and there we go. Congratulations, my friends. We have reached finally the positive average score. So it is really well improving. Plus 9 now, plus 11, plus 12, plus 13, plus 19. So you see how it is getting better and better over time, how it is really getting more performant, how it is learning better, how to land properly on the moon. And of course, in the next tutorial, we'll see the results in the video of that AI, you know, properly trained to land on the moon. We will see how it is able to train on the moon. But as you can see now, we have reached more than 400 episodes and the average score is still increasing. That is amazing. And so I'm very confident now that we will soon reach an average score of over 200. Now we are at 74, 76, and we have reached episode number 423 now. And we're still at 75, 78, still doing a bit more exploration, still updating its parameters, still updating Q values, still applying the epsilon greedy action selection policy while learning with deep Q learning. And the average score is now at 80. So it keeps improving, it keeps getting higher and higher. And we have reached episode 448, 449. The average score is still increasing. Now it is kind of increasing slowly, but don't worry. It will at some point, you know, increase more because sometimes it needs to do a bit more of exploration before, you know, really take a big leap in improvement and in performance. But there you go. Now we are approaching an average score of 100 and we are approaching the episode 500. And remember, the total number of episodes over which we want to do this training is 2000. So we still have some time, we still have some good margin before reaching that objective, that goal of 200 average score. So now we are at 96, we're approaching the 100, and there we go, 100, perfect. So we're getting close, we're getting close. So average score 102, 104, 104 still. So we are now past the episode 500, good. So the average score is around 106, 107, 106 again. So yeah, it keeps improving, it keeps improving. Now it's probably doing some more exploration, on how to really take another big leap in improving the average score. But soon enough, we will see it at 110, and then 120, and then 130, and this will be exciting. There you go, 112, 113, 114, and the episode is at 546. By the way, feel free to share in the comments the average scores you get. Maybe you already won, maybe you found an AI, maybe you tweaked a bit the AI, the neural network architecture, I don't know, but maybe you already got the average score, the targeted average score of 200 before me. I'm at episode 569 and reaching an average score of 121, but maybe you got a better one before that. So feel free to share in the comment, feel free to share your AIs, your architectures, and yeah, probably you will find an even better than the one we implemented together here. Alright, so where are we now? We have almost reached episode 600 and the average score is at 128. So yeah, 132 now, 131, episode 600. So yeah, maybe we will get that final win, that final desired performance at episode 1000 maybe. It can change, it can vary with different experimentation. It's not deterministic at all, so let's see what we get. But now the average score is kind of stagnating. Oh no, it keeps increasing, very good. 134, 133, okay. So, very, very interesting. So, there we go, now we are at episode 650. And so, the average score seems to be still increasing. Sometimes we see it decrease, but that's completely normal. That's because sometimes the AI needs to do some more exploration to explore more actions that it can do in order to achieve the desired performance. But there you go. Now we are over 140 for the average score, and we have reached almost 700 episodes, and now over 150. So we're getting close. 153, 154, 154. We have reached more than 700 episodes now. So yeah, I think this is what I said. We're gonna finally win around 1000 episodes. So you see, we really don't need the 2000 episodes in order to achieve that final performance of the average score around 200. We are over 165 now. We're getting close. That's great. That's great. Maybe we will actually win before 1000 episodes. We could have actually, do this training over 1000 episodes only instead of 2000. But at least now we have some margin. We can feel confident that we will win before the end of the first for loop, looping over the episodes. Oh, wow. Now we are almost at 180 and sometimes decreasing a bit, but that's totally normal. That's because of the expiration. But there you go. 183, 84, 82. Oh, that's great. And we have reached 780 for the number of the episodes. So now it's stagnating around 180, but it's really increasing, it's really improving. So I feel totally confident that we will reach that targeted average score of 200 super soon. Now it decreased a bit, but that's again totally normal because of the expiration. It doesn't have to increase all the time. But there you go. I'm just betting if we're gonna reach that 200 average score before 1000 episodes or after. Let's take a bet. I bet that we might actually reach that average score after 100, because now it's doing some more exploration. The average score is decreasing a bit, but maybe at some point it will increase again because it will realize that the direction of the exploration it took is not the right one and it needs to go back to the previous subspace of the actions it took. All right, so 166 now after having reached 875 for the episode. And now it is increasing again. Good. 172, 173. So it found a new, better subspace of the action space, sub-action space. 180 again. Now we're back into the 180. Now 175. Okay. So 175 for episode 916. 174. 180 again. There we go. 182. Oh, maybe I will lose my bet. Actually, maybe we'll reach that 200 reward before 1000. 186. 188. Still increasing. Amazing. We have reached 945, 947, 190. There we go. First time we are over 190. 195, 96. I will lose my bet. We will actually win before 1000 episodes. There we go. Congratulations. We solved the episode in 863 episodes. with an average score of 201.64. Remember, the 863 is because of that minus 100. If you didn't use this minus 100, maybe you actually got 963. But that's an amazing result. Now I can't wait to visualize our AI landing on the moon in this part 3, which we won't re-implement because it doesn't really have to do with AI. It's more a visualization code. So we will just enjoy the results and see our spatially intelligent AI landing properly on the moon. I can't wait to meet you there. Congratulations again. And until then, enjoy AI.